Okay, continuing off the previous video, now I want to talk about vertical lines. So vertical lines are going to be lines that are x equals some constant, x equals c. Now, x could be, any number that you want. Let's just deal with integers right now, but let me draw a line for us. So if I draw a line right here, well, this could be written as, I don't know, say x equals -4. This is a vertical line where x always equals -4. Something that confuses students is that on this line here, see, let's call this, I don't know, -3 and 3. So it's still going through y values, even though x always equals -4. It's still going there, so it can still have the point -4, 3, and -4, -3. So it's going through those y values, but x is always the same. Okay, and if x is the same, just like in the previous video, then the slope is most certainly undefined because we'll be dividing by 0. All right, so that's another way of knowing that you're dealing with a vertical line there. So again, you can go, all of these statements are equivalent. If you're dealing with a vertical line, you're dealing with x equals some constant, and the slope is undefined. So you can go, well, if the slope's undefined, then it must be x equals some number. Let's look at an example and see how this might work as a question. So find the equation of the line that passes through the points 2, 4, and 2, 7. Okay, well, if you didn't just notice that the x are the same, then I guess the first step you would do is you would find what is the slope. You'd have 7 minus 4, 2 minus 2, and then right there you see that that's going to equal undefined, right? That's undefined. And so if it's undefined, then I'm saying that it must be x equals some constant. Well, what constant must this line be? I would argue that since the x point here and x point here is 2, that it must be the line x equals 2. And that's all you would have to do for something like that to find that line. Okay, but these are the types of questions that often confuse algebra students a lot. So I wanted to go over it explicitly. All right, well, if we can talk about vertical lines, we could probably talk about horizontal lines. So how is that going to work with horizontal lines? So I will just draw a horizontal line there. Let's say that this is, I don't know, this would be at 4. Let's just say this is at 4. This would be at the line y equals 4, okay? This is where y is continuously equaling 4, okay? So horizontal lines are y equals some number, some constant. This example is y equals 4. If you have a line with slope 0, and that's because the y's are the exact same, when you take the difference, it's 0, then you're dealing with a horizontal line, all right? So let's take a look at an example and see how this might come up. So find the equation of the line that passes through the points 1, 3, and 2, 3. 2 lines, I'll find the slope, 3 minus 3, and you can see that's going to go to 0, and 2 minus 1, 0 over 1. And we can see that that equals 0. So we can certainly say that we must be dealing with a horizontal line. What horizontal line are we dealing with? We have 3 here and 3 here for the y. So y equals some constant. Well, I would argue it equals 3. So that would be the answer. That would be the answer there. Y equals 3. Okay? So hopefully that helps. Now I want to talk about parallel lines. Parallel lines now we're starting again to, actually comparing two different lines, not just a single one. And this is kind of an illustration of parallel lines. And notice that they're not intersecting. They don't cross each other. And they have different y-intercepts, and that's what makes them different lines, actually, is that they have different y-intercepts. But their slope must be the same. if their slope was even slightly off from being the exact same, eventually they would intersect. So if they're parallel lines, slope 1 must equal slope 2. They have to be the same, or eventually they would intersect. Okay, so when we compare two lines, we can talk about whether or not they're parallel or not. All right, let's look at this example. Find the line that goes to the point -1, 6 and is parallel to the line 3x plus 1. Well, here we're finding a whole new line. We're finding some mx plus b. Okay, now we're told that the line that we're going to find is parallel to this line. And if it's parallel, this one says parallel, then they must have the same slope. And this slope is 3. So since ours is parallel, it has to be the same slope. So ours is also going to be 3 because it's parallel. Now they gave me a point that our line is going to go through, so I can fill that in since y equals 6, and then we have the slope is 3, and the x equals -1 plus b. Okay, now I can solve for b. So I have 6 equals -3 plus b. I can add 3 to both sides, and I have b equals 9. Okay, so my line must be y equals 3x plus 9. And this line is parallel to the line given, and we can see it's not the exact same because the y-intercept for the line given was 1 and ours is 9, but it had to go through this -1, 6 point. All right. Now let's talk about perpendicular lines. And perpendicular lines, they do intersect, and not only do they intersect, but they intersect at a right angle at 90 degrees there. And for that to happen, for them to be able to intersect at that specific angle, well, they're going to have to be the opposite sign because they're going the opposite way. This line is going positive, and this line is going in the negative direction. So for them to be able to intersect in this manner, they have to be the opposite sign. And they also have to be reciprocals of each other, and that's what's going to make that 90 degrees. So here's a little formula for you, that they have to be opposites, so you have the negative sign, and they have to be reciprocals, so you can just 1 over the original one. Let's look at an example of that and see how that might work in a question. So find the line that passes through the point -1, 6 and is perpendicular to the line y equals 3x plus 1. This is almost the exact same question that we just had, except now it's asking for perpendicular. Okay, well this slope is equal to 3, and we want a perpendicular slope to this one. So our perpendicular slope can be written as -1 over 3. Okay, so this would be our slope for a perpendicular line. Now they want our line to go through the point -1, 6, so I can have y equals mx plus b, and that's going to become 6 equals -1/3 times 1 plus b. Okay, I just need to simplify this, so it looks like this will become positive. And so b will equal 6 minus 1/3. And that would be the same thing as 18 minus 1 over 3. And it looks like b would equal 17/3 there. Okay, so our line must be, I'm going to go over here, y equals mx plus b will become y equals -1/3 plus 17/3. All right. So again, the perpendicular is the opposite reciprocal. So we took the slope that we're given, and we took the reciprocal, and we made it the opposite sign. This one was positive, so we made it negative. Okay, so I'm almost out of time for this video, but I hope that helps, and please reach out if you have any questions.